Ladies and gentlemen, welcome to our new episode of the SETA Tech Talks. My name is Associate Professor Erman Akıllı.
And I am Gloria Özdemir. Thank you for joining us today in our 10th episode of SETA Tech Talks. We've been here for a very long time with you discussing a very broad topics and issues, and indeed space technologies has been one of our main focuses during these episodes. And today we are with a very special guest to discuss with you not only the space technologies and how they have developed lately, but also their combination as well with artificial intelligence. Loay, thank you very much for being here with us today.
Thank you for having me.
Thank you for joining us today, dear Loay. As the tradition of our program, I just would like to give a short biography of our valued guests. Loay Elbasyouni from the Blue Origin. He's a tech leader and entrepreneur renowned for his pivotal role in the NASA's Mars Ingenuity helicopter, where he led the development of its popular propulsion systems. His works spans major projects, including the first Ford electric car and the Blue Moon lander for the Artemis 5 mission. Currently, Loay is focused on AstraQua, a company specializing in autonomous AI-driven exploration robotics. Before going further ado, I would like to start with the first question. Thank you again for joining us today, dear Loay. Well, let's start with the first question. Currently, we are witnessing an unprecedented era in space exploration, with its significance reaching new heights. Could you elaborate on why space exploration is becoming increasingly vital at this juncture? Additionally, what are the current predominant trends in this field? How have private entities influenced this evolution, especially for the international system? The floor is yours.
Thank you. First of all, thank you for having me, inviting me on the show. Space. There's a huge, the simplest way to put it, there's a huge transition in the space exploration, the space industry, from being like a solely politically driven, from the 60s, honestly, it really started from the from the 40s, when the German first, probably for the first to reach space, and then continue after the fall of Germany with Russia and the United States into the space race. So it was completely driven by political reason at the time, it's more like a challenge, and then it got a lot bigger after Kennedy and Kushner of Soviet Union, they kind of decided to, instead of competing on missile programs and things like to have maybe more competition into space. And that drove a lot of space innovation, but also limited the space, since the creation of NASA, it was that's the first really civilian funded, separate from the Department of Defense, because before that there was really a lot of lack. So that was one step in transition into space exploration, is actually the creation of NASA. And then it's was part of it actually transition a lot of these technologies into other private sectors. So that was that's how we got a lot of technologies transfer from space exploration actually into things like you use on your phone, or solar panel or things like that. And now we're going actually through another big stage. We have been going through in the past few years by actually transitioning to more private. But even when I say the word private, even in the past, a lot of private or public companies did a lot of the work for NASA, and that's actually continue. But the difference now today is a lot of companies with rich businessmen, at least like SpaceX, Blue Origin, and there's a few other, almost sparked a new space race, but it's also driven by the needs we need. So there is a huge market for space exploration. Especially low Earth orbit satellites, and also exploring going to the moon and Mars. I'm still I don't know, you gotta really talk about the profitability in the long term in that, and where's the aspect. We never know until we get there, right? So
yeah.
But that transition kind of switch where the entire projects today, becoming almost the approach SpaceX took early on, It was like, you know, how you actually can design everything from one perspective, like from like, you know, and instead of like working with, you know, like in the past, like still private company, like develop like, you know, like Apollo 5 mission, you know, to the moon, you know, but still like a lot of these company were driven, the project were managed, the specification were written by NASA, you know, and there was like that actually created a lot of lag, and sometimes it actually added a little bit of cost because, you know, there was too much, you know, there's basically a middleman, you know. So the new space is basically you kind of take that middleman out, you know, and you spark a little bit of interest within like NASA. So NASA probably contracting like SpaceX and other companies. I mean, you know, like, I mean, there's so many companies. I don't want to like just kind of focus just on SpaceX, but you know, I mean, you know, it's like Rocket Lab. There's so many. So I mean, the prospect of space exploration, so that actually a little bit reduced the cost because, you know, now we, you know, one, like we basically trying to mass produce technologies we had. I mean, we advancing them a little bit. So I mean, you know, you know, I still do not believe there's a huge breakthrough. I think the biggest breakthrough is like by, you know, figuring out the manufacturability, making it more similar to other industry where you actually can manufacture multiple units, you know, because in the past, you know, like, and I want to really iterate on this because, you know, there's a big misconception about this subject. You know, like if you design one rocket, a lot of people associate the cost of the design of one rocket to the associating cost of this, of actually delivering more rockets or other things. You know, anything NASA worked in the past was really basically a very advanced prototype. You know, I mean, you know, yes, I mean, we had a lot of flight on the space shuttle, and the purpose was the reusability. So the idea of reusability and cost was actually introduced with the space shuttle program, you know, because you were trying to reuse a lot, you know, the same thing. But the cost is still limited because, you know, when you look at engineering in general, you know, I mean, anything, any product you design, you know, I mean, the cost of the product is, you know, is like the cost of the development is divided by the number of units, you know. So like, you know, that's why we could make a very advanced, like the most advanced probably tech we have today is probably, you know, a phone, you know. I mean, I don't want to, you know, I mean, you know, like we just because the cost of development get divided, but like billions of phones, you know, like you'll be able to create a phone really cheap, like, you know, for $1,000. And people still think it's expensive, but that's why like we can keep developing these phones. Like every year, 2 years, you have to like, you know, it's like it's more advanced. So if you take the same exact model now, like, you know, I'm developing one rocket, you know, or one system, you know, but I'm doing exactly the same thing. So that initial cost is getting divided. So the more units you build, the lower the cost become. So that's where we're transitioning now. So like, yes, we cannot get like, you know, the people in the politics is like, hey, we need to change every rocket, we need to get it more advanced. It's like, no. If it's meeting the mission, we continue with that cost model, and that, you know, and then you keeping like, you know, and that will help you in the future. So that creating a whole new region, you know, because now accessibility to space become a lot lower. So sending a payload to space, it doesn't have to be like a satellite only for the government. You know, any companies, you know, could send a satellite, you know, because I mean the costs become a lot lower. So that actually created a lot of companies like, you know, in the satellite space into like other, you know, I mean, there's a lot of companies like actually exploring like other ways of like reaching that, you know, and the accessibility to space make that a lot more affordable, allow the creation for a lot more companies, allowing the innovation of like many new things like, you know, we didn't think about in the past. Was like, you know, getting a satellite image, you know, from like a company like Planet or Maxar. It's not only limited to NASA and the Defense Department, you know, I mean, there's private companies capable of doing what these other people were doing in the past. So that's kind of like the transition we kind of seeing. I mean, I see that like, you know, becoming like, you know, these profitability models, like, you know, it actually allow a lot of new customer getting in, you know. So like now, not only like these private companies, you know, I mean, you know, and like, you know, start branching out into other things like space tourism, you know, like, you know, I mean, there's a lot of things gonna keep happening. I mean, it is really, I mean, yeah, I mean, it's like, you know, it's kind of funny, like even like by actually making even, because people's like, oh, what's the advantage of space tourism? I mean, you're increasing the number of rocket launches, you're increasing the number of test data, we're developing like, you know, space rockets a lot more, become more advanced, you know, so like, you know, like, and that will overall
it brings innovation with it also.
Yeah, I mean, you know, like, you know, a lot of times like we don't really know what we're inventing until we actually start working, you know. So I mean, you know, I mean, and this is really the notion is like, you know, like sometimes you have to create a problem to find a solution.
Right?
and literally that's how we invented like solar panel, because we had a big problem. Like we could only send a satellite to space. it wouldn't last that long because like it could only carry so much energy. So they had to we invented solar panel, so and make it make satellites a lot more usable, last for a lot longer time. I mean, the same thing. It's like we discovered GPS by an accident. I don't know if you know the story of Sputnik. I mean, the Russian satellite, and two American radio engineers were listening and like, oh, there's different in the time. We could probably figure the location of based on that. So and I mean, it took many years, took about 30 years before we got in consumer products, but I mean, still, I mean, so things come along this way. I don't know if I answered your question or not.
Yeah. So can we consider the James Webb Telescope for like finding new problems and also for new solutions as part of the initiative for the private sector?
I mean, so there's this whole other aspect, right, from space, from actually studying the cosmos. So there's the physics aspect to it. It's like we're studying that will help us completely different than the technology path, because but the more we understand about the difference like further away, which is like the knowledge we get from space, like like James Webb, like actually helping us quite a bit. I mean, in terms of like, I mean, even the technology we're used in developing James Webb, I mean, it's like there's so many, imaging technologies, sensing technologies, like the way they actually have done like the mirror, I mean, it's like that's actually one of the most coolest thing ever, I mean, like probably on the space, like how can they actually created this material and how you made it in a way you could open it in space without like damaging it. So like, I mean, that's like in terms of the technology transfer. So I mean, so there is actually a program in NASA called technology transfer, where they allow some of these IPs being developed, being transitioned, not allowed. I mean, it's part of the purpose of NASA. When NASA was created, like, like for civilian use, it's like, we cannot really just have this technology go. So like they created this program called NASA spin-off NASA technology transfer, where they transfer a lot of these technologies. But on the other aspect, like exploring the space from like from like the astrophysics standpoint, it's like understanding that's deeper means that's like completely different. So I mean, there's this two different paths, I guess, of space, which is like one is like we are using here on Earth, and then there's like, okay, we just exploration for the sake of exploration. I mean, why do we explore? Just because we really can, so
So, Loay, I will go a little bit into more details right now. Like we spoke in general about the space technologies and how they changed lately. And I want to focus a little bit more on a project that you've been part of, which is the Ingenuity Mars helicopter. Like, indeed, to tell the truth, we have a common friend with Loay, and I was talking with him some couple of months ago, and he was like, I have a friend of mine who works for NASA and Blue Origin, and he has created the first helicopter that went to Mars. And I was like, wow, what's that? Like, I didn't heard anything about Ingenuity before, and I was so like overwhelmed to keep reading about it and thinking the importance of this project. That's why I wanted to ask you something about that for our audience. Like, maybe they don't know, like the helicopter. This is one of the Ingenuity is one of the most innovative helicopters, and which accompanied the Mars Perseverance rover in 2021. And correct me if I'm wrong, but it was supposed to stay there to work there for a couple of months, but it exceeded these expectations and was there for around 3 years, right? And it has served also not only it is not only important for what it did there, but it's also important for the fact that it has inspired a lot of other innovations. And because of Ingenuity, like NASA right now has is supposed to create 2 more advanced helicopters, which will retrieve the samples collected by the Perseverance on Mars previously. So, like, can you share a little bit insights about this project with us, like its importance and the current applications of it right now?
Yeah, so honestly, the helicopter, I mean, like the simplest one line I can put it is like that's where like science fiction becomes science fact.
Yeah, exactly.
So like and it's not even about, I mean, I would even say it is like probably the most, you know, an advanced technology, you know, because like we use literally, because to make it possible, we use a lot of things that are extremely simple, and sometimes like, you know, focusing on solution is not the best technology, it's not the most advanced things that will get you there. I mean, the helicopter idea is like, actually we're only supposed to fly for 1 month, like 3 to 5 flights. We flew about 72 flights. So
That's perfect.
you know, and the mission had to be extended many times because, you know, it kept exceeding expectation. But I mean, like in the early times, I mean, I worked on the helicopter from very early on, and it's like, to me, it's like the helicopter, I mean, honestly, it's like it's a kind of resemble sometimes a little bit like, you know, like a struggle of any even person, you know, because like, you know, everybody was against it. A lot of people did not believe it was possible. A lot of people did not think, you know, we could do this. I mean, you know, but it's like, you know, our faith, our belief, like literally, like, you know, part of it, my belief, and a lot of the other teams, like, we took it extremely personal because we wanted to make it happen, you know, and you know, we had to prove like every single step of the way, you know, like, you know, convince like the entire leadership of NASA, you know, I mean, like, you know, like this is, you know, like, you know, that's going to be successful. And actually they did not send it until actually succeeded in the simulation on Earth. I mean, you know, just to tell a little bit, I mean, the helicopters, you know, I mean, the biggest problem is, and you know, I mean, you know, it's like actually there is almost no air on Mars. I mean, it's like about 0.6%, which is, you know, less than 1% of the Earth, of the air on Earth, and you need air for flying. So, which is like a lot of people, like, you know, it's easy to say, oh, there's no air on Mars, so how can you fly? You know, because like, but you know, taking that tiny 0.6%, you know, and designing something that, you know, I mean, that's where a lot of the innovation was, is like, you know, designing something from the structural level that could handle the mission, and in the same time was able to create liftoff. You know, it was extremely challenging, and then that created all these like stack up weight. You know, how can we build something? Because a lot of time, you know, people was like, oh yeah, well, you know, you can do it. You can just put an NVIDIA chip on it. I mean, I do a lot of talking. Sometimes people like, did you guys use an NVIDIA chip or use GPU or for like image processing? And I was like, you know, if I put one on, like, it will never fly. So, you know, so it's like, you know, how can you really make something while you considering, you know, like your ultimate mission for like the helicopter, the mission itself, the limitation is actually the physical limitation is actually the air, you know. So to be able to fly in that, we have to really talk about, you know, like, you know, it's like, how can you really make, like, it have to be certain weight, you know, and then it's like, how is that translating to like every single part, from like, you know, a small resistor, or like, you know, from the blades using carbon fiber, or, you know, or it's using like, you know, we use a lot of earth-rated electronics, because a lot of the space electronic design a lot bigger, they design for a much harsher environment, because, you know, I don't want to say maybe close to like, you know, 500 to 1,000 times more, you know. And, you know, and this is actually a limitation for a lot of the third world countries, or like countries do not have access to very advanced chips, you know, do not have like access to like defense chips and things like that. You know, I get this question a lot. It's like, yes, you can use automotive, yes, you can use consumer parts, but you have to really understand the mission and mitigate a lot of these problems. You know, I mean, you know, industry develop in a way, it's like, sometimes we kind of become addicted to the processes and the system we created for ourselves, that sometimes like that will actually halt advancement. Like, and you know, and that was one of my biggest challenge actually in the helicopter. I got a big resistance or pushback to use like earth-rated electronics, and I was like, yeah, but you know, it's about the system. I can make a system that function, you know, and we came up with all this mathematical probability to calculate how we're gonna survive the space radiation, using a lot of like earth-rated parts, because nobody have tested them before for space application. So that kind of pushed our, like, you know, made us like allow us to like, you know, use different parts, you know, I mean, like literally like it used, you know, I think probably like, you know, like the Snapdragon processor, which is like, and using an old probably Samsung phone, you know, it's like, you know, and so it's like, you know, sometimes it's not the most advanced technology is required, you know, and like, I think that's a lot of time we limit ourselves by replicating our competition, you know. So, and what I mean by this, I mean, like, I see this a lot, you know. It's like, you know, you see somebody like, you know, like having a very, like, let's talk about cars, you know, it's like somebody having a very advanced, like if Ferrari make a car that look super fast, blah blah blah, you really cannot start a car company by trying to become Ferrari, you know. like the best way to succeed is how to find something, you know. And I think like sometimes like, you know, be like, what do you mean by that? I was like, you know, sometimes like if you go to Southeast Asia and you discover that tuk-tuk, you know, was a solution to replace a lot of cars because they could not afford cars, but they came up with an innovative solution that actually produced a lot of higher numbers of, because the goal was transportation, you know. So I think a lot of time we in design we miss and forget this part, and that's what makes us sometimes we don't have access to this. We don't have these advanced chips from NVIDIA. But, you know, like if I decide to use them, we will never flow them because like we will not be able to power them or carry the weight or the heat sink to cool them, you know. So, you know, but so like sometimes like I think that's a limitation, you know. So, you know, usually it's like this is, you know, I'm kind of going on. It's like be creative with what you have, you know, and that will allow you to advance a lot further. And sometimes you're gonna replace, like, you know, how the future of drones gonna replace aircraft, you know. It's like, you know, is there any value to the F-35 today? You know, I don't want to disappoint anybody, you know. A lot of people in government gonna get disappointed, but I
There's a
say
lot of money
I
going
think it's
on.
like a very high cost object that, you know, it's a matter of once you detect it once, that's it. Everybody gonna detect it after, you know. So, but I think like, you know, smaller drones could do a much better job. That's just, you know, you know, just an example, you know, like, so, you know, so like the approach to the market sometime, you know, like, you know, this limitation, these restrictions, even I want to say this, even if you have sanctions, you know, sometimes they advance you because you have to find an innovative,
I think
way.
Turkey is the best example of this, right? With the drones.
Yeah. That's why it's like, you know, I have so much respect for Baykar and what they're doing, you know. But, you know, but yeah, so I mean, you know, and I think that's a good example. Like, you know, I mean, Baykar, Turkey, you know, it's like I think it's have a really good model for moving forward. You know, but I mean, this is just an example, you know. It's like, you know, I mean, there's many examples like this. It's like how the tuk-tuk, you know, like replace a lot of cars in Southeast Asia, you know. It's just because, you know, they could make a smaller motor, they could make, you know, like weld bunch of steel together. They didn't have to make a very advanced car that meet all that European, American highway safety regulation, you know, which is literally it's the biggest nightmare if you ever worked in a car, you know. So, but it's like, why do you want to, like, you know, it's like, you know, like you have to really work within your limitations, you know, and just find the market, and then you can build on it and grow. So,
is Ingenuity still working right now, or at least like
no,
what's going on?
Yeah, sadly, it crashed a few months ago. I mean, I don't know if I kind of lost track in the last year, but yeah, I mean, it crashed in the 72 flight. You know, I mean, it broke one of the props, one of the blades. You know, it snapped. I mean, but you know, I mean, it's a great mission. You know, it's like every day when it did another flight, I don't know, even a couple of times when it stopped communicating. I don't remember the flight number, but I thought it was dead, you know, and everybody thought it was dead, you know. So, but then it's like it showed up again. So, but this time it's broken, you know. So,
Loay, do you create some kind of connection with the helicopter, for example? Like, how does
But
it feel?
it
You
sounds
know,
a fighter, you know,
like
the
a
helicopter.
person. Do you create a personal connection with that? Like, for example, if you get a message or not like if you get a signal from it or not, like, I don't know, do you create this personal connection between you and the helicopter sometimes? Like, how does that feel?
I think that's more spiritual, you know.
Yeah.
I'm sending it signal, you know, like I'm
Yeah.
praying, you know. No, I mean, you know,
but
I'm
the
not.
thing is,
Yeah.
that helicopter must be a fighter, because as you says, you thought that it's that, but no, not at all.
You know.
It came back.
Yeah, you know, like, you know, it's kind of like me, you know, you cannot give up, you know.
Yeah.
I resemble my personality similar to the helicopter, you know, against all odds, against all people, you know, dispute.
Persistence is
It's
very
not.
essential.
I mean, it's not only about persistence, you know. It's about doubter. It's like how you really continue in what you believe in. I think the world, a lot of people in the world, look at others as like, you know, they are more lucky than they are, and probably not. You just have to believe in yourself. I think it's extremely important
So true.
to always to know that you can do it. And a lot of people look at things. That's what it's like. I said, it's like, yes, if you look at F-35, you probably never think you can do it. But if I say look at something else, like if you want to make a car, make a tuk-tuk first.
Yeah.
And then your mind will change. It's like, because like we limit our ceilings by the impossible, and then like even sometimes the people around us not really necessarily gonna support us, even the closest people, because even I say this a lot to a lot of my friends, like to your parents, I mean, they love you, I mean, they love us always, right? But to us, to them, we are always the kid, because that's the image in their mind, that you're the irresponsible kid. They probably like know some things about you. Or me, like I don't know about myself, right? They know when you're gonna struggle and when you're not, because they associate when you're a kid. So sometimes, like it's like you cannot really take everybody's opinion. It's like you really have to like believe in yourself, believe in your mission, have a plan, and work on it. And and that's what we really did with the helicopter. That's like a lot of project I worked on. It's like you just have to really believe, have a path. I think the helicopter is extremely incredible, because in the beginning it was a very low budget. The total number of helicopter built were 3, including the one on Mars. So if any engineer sitting here and he's like telling me, he's like, yeah, I'm at prototype 20 or something, and I was like, yeah, but we didn't have that luxury, and we didn't have the luxury of like testing it and like redesigning it, because we don't have Mars, right? So we had to like figure a lot of things, even sometimes like how can we make the gravity on Mars. So like we had a string holding it, counter the weight, so like so it's like so which is like really simple. It's like, how can you create Mars gravity? It's like, oh, you just connect the string and put 2/3 of the weight on the other side. I mean, it's that simple, because you just lower the weight of it. So I mean, and that and that will really just make you creative, give you like belief that you really can do it. I think believing, I mean, I use the word believe a lot. I think that translates in Turkish to iman, which is sometimes people associate it only with religion.
Yeah.
But
that's the script word, believing in yourself.
Yeah, but it's like I mean, it also come from that. I mean, there is a big thrive. It's like when you really have a strong belief, and in whatever, it's like it's gonna like make you more powerful. Like it's gonna make you more insistent. It's gonna make you persevere to achieve whatever that ingenuity is.
Wow. With your permission, I would like to take the topic back to the skies, back to the space again.
Sure.
Yeah. Apart from your other achievements, which are quite impressive, to be honest, but your involvement in the Blue Moon project is quite impressive as well. So I would like to talk about the Blue Moon project, with your permission. So what does it achieve for? And can you please just tell us about the project?
Yeah, I mean, I'm gonna be limited to what I can say here, because I mean, I cannot really talk about things that it's not in the public. But I mean, like, so I mean, there's no achievement there yet. Haven't gone to the moon. So the I worked on developing the avionics for Blue Origin, like the engine avionic team, which is basically all the different rocket engines, is like BE4, BE3U, they're all like in the public. BE7 is actually used on the Blue Moon. So I mean, I was working on that, and my team actually developed all the hardware for the different rocket engines. So Blue Moon is actually going to be, the craft is going to be used for Artemis 5, which I believe is scheduled in 2030, which is returning people to the moon, returning humans to the moon. So the Artemis, I don't know if I could speak more about the Artemis program. So I mean, Artemis is, which is basically, we already had Artemis 1. I think we got Artemis 2. So on Artemis 3, I think they're gonna use SpaceX, Starship, and then Artemis 4 go back to the Orion, and then I think like Artemis 5 is gonna be Blue Moon. So
it's so sorry, but I have to add this. But the idea of going back to moon, it's so exciting. It gives the chills. Like it's like almost 80 years to going back to moon.
Yeah, but
And
we're not.
finally, maybe we can able to see more about the moon. Who knows?
Yeah. So I mean, at this time, it's not only about just going back to the moon. I mean, it's not like an Apollo mission. I mean, we go into the moon and we're staying, so it's a little bit different, So I mean, there is companies like working on the base, on the moon base. It's gonna probably be some activities on the moon for further space exploration. So, I mean, you could think of the moon as a bus station, I guess, or like train station that can be used to go to Mars next, because like it's a lot more cost effective and environmentally friendly to actually launch from the moon versus launching from Earth to not Mars and other planets and other exploration mission.
Finally we are going to leave the sci-fi future.
a little bit. It's not really sci-fi as much as you think. So I mean, the plan is actually to have like a permanent.
It reminded me the famous movie Total Recall of the Arnold Schwarzenegger.
Yeah.
Yeah, they first stayed at the moon and then go to have just like a summer vacation to the moon, to the Mars with his wife. Yeah,
I'm thinking about maybe opening a hotel there one day.
a boutique hotel, just small and cozy.
Yeah, my friend was like, maybe we should host, if you do that, you should host a basketball game. It'd be really interesting to watch a basketball game on the moon. I think that would generate a lot of money. Yeah, where's the ball? I think that would be like, I think that would be the most watched, sport game in the world. Basketball on the moon. But yeah, so I mean, like back to the Artemis. I mean, Artemis is just only to. So I mean, they're gonna be this whole ecosystem. They're gonna have a station. It's called the Gateway around the moon. It's gonna be these launches from the moon surface. Blue Moon actually will be used to the Gateway, and from the Gateway to like outside of Earth. So I mean, there's a lot of different phases, and it's gonna be like building the infrastructure to keep like developing on in the future. So I mean, my contribution, I mean, it's not really that much, but it's mainly just on the rocket engines, like how to like basically the avionics is basically how you controlling the fuels and making the engine run, so but so I mean it's kind of it's really interesting. It's a little bit a little bit different than what I have done in the past, but it's like I mean, I'd give me like more into like the space, deep space exploration, and also like the deeper space engine is a little bit different than like launching from Earth, getting to low Earth orbit, because a lot of time you don't really have to handle the space radiation. So when you go into deeper space, a lot of these requirements change. But yeah, I mean, we can stay into the science fiction, sound like more exciting.
Yeah.
Loay, I wanted to ask you a little bit about your current company. Because Erman mentioned that you're currently working on AstraQua, which brings together two of the most important topics, like AI and space technologies at the same time. So specifically, like as we mentioned, you focused on the autonomous AI-driven exploration robotics. What do you think? Like, can we consider this as a new chapter in space technologies, like the inclusion of AI in here? And what should its impact be in space exploration and maybe like in general more in space competition as well?
Yeah, so no, I mean the use of AI. I think AI is a widely used word. So I mean that's why it's like I use actually autonomous, because and as I said, like every mission you have to really have a specification to the mission and limitation. So I mean having open open AI, but it's like AI in general is like it's just like a really wide word, because like I mean a lot of people like use it today to refer to regenerative AI and things like that. But I mean autonomous system. And there is like AI on studying the data. So a lot of the data we're getting from space. I mean, there's a lot of application now is actually to use on board, because like AI like come down to the computation, which is like a lot of time like in modern days use GPUs for it. So we really do not have a clear. I'm studying this subject right now. Is like the use of GPUs and like equivalent like AI computing in space. it might be actually limited because of space radiation. I don't think, I think that's like, it will be challenging, but also like, adding an AI in the general genre of like, hey, I'm a conscious computer, right? It's because like, I mean, sometimes people associated with that, like actually a consciousness to some degree. I think that will be like limited based on the system, on like actually the mission, So like what we're working on is a little bit different because we actually want to advance autonomous systems using AI. So we actually, it's almost like we'll have like a computer. So I mean, the whole idea come actually from working on the helicopter, and because like we just, I mean, one of the biggest thing is like the biggest obstacle was not actually the technology. It was actually how can you get the technology as light as possible, So, like having the computing, the processing power is very limited, because if we increased it, we increase power. When we increase power, we need to decrease the battery. If you have a higher CPU, you need a bigger heat sink, you need to cool it down. So now it's like you're carrying more weight and then all of a sudden you're not flying, So, so how can you actually make, but, so we made a lot of missions, in the helicopter, and there are many iterations into the autonomous software because the helicopter is autonomous. It have like one routine that does imaging, image processing, but it's limited when it's landing. So it's not really like, the helicopter cannot take off. It's not fully aware. It cannot really do things without we telling it. And I believe like robotics, I mean, we have robotics for a very long time. Most robotics in the past has been limited. I think they will still be limited, but we can speed up how we actually program them and how we actually be able to change the mission, which is something we did with the helicopter. But with the helicopter, we had like about 40, 50 engineers back here, like have to test everything, do everything. A lot of time it took a month or a month before we can run a next flight, So because, because the computing is limited, you could not add all the feature. And then sometimes like, hey, we discovered we need to change, this part of the code or something like that. So AI itself, I mean, yes, you can use AI from the point of view of designing and advancing technology. You could use AI from studying the data you get back, which is like this, data mining and, to like find patterns to improve on things on the future. But like, I think like it's like AI itself to have like a robotic AI, or AI in robotics, I think it's going to be taking us a longer period of time before we actually could have that, unless we have, I mean, we could start, I think you hear a lot of people talking about nuclear powered like data center, but then you have to really imagine that a lot of the robots will actually have to be also like nuclear powered. I mean, actually the Perseverance rover is nuclear powered, so that's really kind of a limitation. So it's going to be like a trade-off based on missions. I think the companies that going to focus on like going all the way, they might probably actually find themselves, like restricted. I do believe there is this transition is going to take time, and, I don't even know what's really the full. I really wish if somebody could clarify what is really AI in terms of like,
you're asking something very difficult right now.
Yeah.
But so I mean,
$1 million question.
Yeah, I mean, that's why I prefer like, I mean, we are AI-driven robotics, because I mean, we'll use AI to advance the autonomous systems, but I think missions will be limited to autonomous, This is really a common problem, I face a lot with a lot of young engineers. A lot of time, they just want to use the best thing, it's like, what is the best part I can get? And it's like, it's like there is a reason why a company still sell very old processors, computing processors sometimes. I mean, it's because a lot of things based on mission is based on cost. So a lot of these things are actually it's very important to consider in development. Is like, how can I keep the cost down while I meet the mission? Because the goal is like I said, we go back to the tuk-tuk, if you're gonna go from point A to point B, the tuk-tuk is gonna do the job, and they're kind of a little bit dangerous, right? But they meet like 95% of the other requirements, So I mean, when that secure, I mean, they don't go that fast, so the danger is not as much, right? So, but there is limitation, right?
So it is intentional to making them go slow.
I mean, no, because it's limited. If they go really fast, I mean, I've been in Southeast Asia, man, and some of these tuk-tuk drivers, they like hack their tuk-tuk and make them go fast. I mean, I used to work on golf cars design in the past, and we actually hack the golf cars and we make them go really fast. And they're like, instead of 5 miles per hour, which is like 7 kilometers, they go 35, like 50, 60 kilometers, in a tiny golf car. Can you imagine a golf car going like,
it's just like that wish,
I can tell you how to do the hack, in the old golf cars, like their DC driven motor, you just take the cable from the battery.
Okay, well, now we are cutting this from here. because we are youngster audiences as well. Maybe later, okay?
Maybe later, yeah. It's good to have some, technical friends, like who know the techniques. Like they can be quite useful sometimes.
I try to stay technical. It's hard sometimes, but.
No, that's a very good point. There are so many things that we have to learn from you.
Yeah, exactly.
Loay, it was a pleasure to have you today, and there's a lot of things that we can sit and discuss here, but we try to keep these programs as limited as possible, so it will not get kind of like, how can I say, like boring also for the audience. And we don't also want to tire you, because it's like we've been talking for 40 minutes, and we don't want to take much of your time as well. But before closing, we talked a little bit about the fact that to be successful we have to believe in ourselves, but still, I would like to have some sentences from you, that can inspire also the young people here in Turkey, because your story is very, very it's emotional, but it's all, at least taking into consideration what's going on right now, but it's very inspiring as well, originating from Palestine and leading to becoming a prominent space exploration engineer in the US, despite the various challenges that you may have gone through this period. And this is very remarkable. So, I can really say that your story indeed serves as a powerful inspiration. And as I mentioned, especially for the young students here in Turkey. And indeed, it's important for us. Your story is important for us for the fact that in Turkey, right now we have been focusing very much on the space exploration. Before starting the program, we talked about the satellites. We had the first astronaut being sent to the space at the beginning of this year, and so taking all this into consideration, what advice or suggestion can you give to the young minds here in Turkey?
I mean, one, I already said it. You gotta really believe in yourself. You gotta have passion. I think one of the secrets to success is you really gotta love what you do. If you don't, I think you might struggle. You gotta really have that passion. It's gonna help you with you gotta believe and have passion. And then have a purpose. It's why you're really doing things. That also help you drive you in the downturn. You're gonna face a lot of challenges from people. Not everybody gonna believe in what you say. And a lot of people gonna support you. Even the closest people to you. So sometimes you just have to understand what angle they come from, but just respect it, and just you gotta be persistent in what you really want. That's gonna help out a lot. And sometimes you don't really have to look far, because you can look. Actually, I spoke with a lot of students. I give a lot of talks in Turkey, so I met a lot of students, and sometimes you really do not know what's far. If you don't know what's near. What I mean by this is a lot of people look for larger ambitions. Hey, I want to work on the F-35. I'm go back to that thing. But I was you will learn a lot less than if you really work on a really small drone. So that's just for an example. If you work on a small robots that you could be part of every single part of it. It's different, if you really end up working, for example, you just even throw it out, if you end up working at SpaceX, you probably end up working half of your career, just in a couple parts, because the things, when the bigger they get, the smaller you become, so look for opportunities around you. Look how to be innovative. Look, I mean, I think Turkey offer a lot of potential in terms of for people, for entrepreneurs, for startups. I mean, I've been like recently observing like the Technofest. I mean, there is a lot of these opportunities. I think people should consider it. And like also like you cannot do things alone. I mean, sometimes this is become challenger. Like the more experience you have, but like like early on in college, you have a lot of connection to other students. Just like you really have passion. Build better future for the people you care about. And just have that passion, and that will drive you to success.
Thank you very much, Loay. These are very, very like important advice for our young audience in here, and we really appreciate that. Thank you very much.
Thank you for having
thank
me.
you, dear Loay, for attending and being with us today here. It was a great pleasure to have you in our program, and hope to see you in our future programs as well.
Anytime, I'll be happy.
Thank you so much.
Thank you very much for everything.
Thank you for having me.
Bye-bye.
Bye-bye.
Well, ladies and gentlemen, thank you for being with us as well. It was a great program as always. For myself, I'm sure Gloria will also share my thoughts. We learned a lot thanks to Loay. It was quite inspiring, and having a deep knowledge about the space and the AI nexus. It's always interesting topic for us. But nevertheless, it was a great joy to having the first-hand news from the Loay. And thank you for being with us as well as our audience in the last very late night. But nevertheless, thank you for attending. Hope to see you in our next episode in the Tech Talks. Thank you.
Thank you.
Thank you.